Hi friends and welcome back. Today we'll be discussing hyperparameter tuning in machine learning, and we'll discuss these two hyperparameters, grid search and random search. So this is me. Okay, let's start. So what is this guitar doing here? I just want to give you an example of guitar tuning. Just before a performance or playing a guitar after a long time, you tune it so that it gives you a good sound and which is pleasant to hear. Similar is with the tuning of a parameter so that they give you good performance. So coming to hyperparameter tuning, this is the final step before you deploy your machine learning model. So I would say that before you predict your data, or you predict, do it for test, give your model for testing, you do some hyperparameter tuning so that it gives you good performance. Then what happens is it improves performance because your parameters are being hyper tuned, and these hyperparameters, they are not learned by the model. Okay, so what's next? That actually hyperparameters control how the model behave, right? And it contains arguments like C, kernel, gamma, alpha for different estimators, which we'll see. And what happens is we select the best parameter and we use them to build the model. So this improves the overall performance of the model. The two common methods for this hyperparameter tuning are grid search and random search. So as the name suggests, grid, it is doing grid search, and random, it is doing a randomized search. And we've got respective function for this in Psychoplan: randomized CV, grid search CV. CV is cross validation. So now moving on to grid search and random search. So grid search, this exhaustively considers all the parameter combinations and they are evaluated and the best is retained. What happens in random search is it performs a random search on specified parameters, and then the model is constructed on those parameters and evaluated on the given parameters. Now this, as you can see now, when the grid search is exhaustively doing a task, that means there's high runtime involved and this also gives you good performance. But when you come to random search, this will lower your runtime, so it is good computationally, and this can also give you a little less performance over grid search. So another application is that when you've got huge amount of data, like tens and thousands uh, parameters to tune, you will use random search because the runtime is low and it can actually boost up your performance as compared to grid search, which would perform good when the parameters are less, right? Next, we come to this figure, which just tells me that this is the grid search and they've got this 9 trials, and only the best, see, only the 3 distinct, I would say only test 3 distinct places. Alright, this grid search with these 9 trials only test 3 distinct places, and this random layout, the search all the 9 trials and explore distinct values. Okay, so it is giving me different, exploring different distinct values in this. Okay, now what happens also here is that in grid search you set up a grid of parameters, and for each combination you train a model, and the score is being tested on, or you can say it scores on the testing data. And in random layout, what happens is, or in random search, you set up a grid of hyperparameter values and select random combinations to train your model, and then scoring is done on the testing data. Now this is an example from Scikit-learn I have taken, and just I want to show you that the randomized search took 19.80 seconds for 20 candidate parameter setting. So it's randomly choosing 20 candidates or 20 parameters, and the grid search is taking more than 113 seconds for 100 candidate parameter. Okay, and you see this model with rank 1, and the mean score here is 0.92, and the parameters are alpha, average, L1 ratio, which has been for this example. And for grid CV model, you've got mean as 0.93, which is higher than the mean of model 1, which is 0.92. And the parameters again are the same, alpha, average, and L1 ratio. Similarly, you can compare it with various models, and the rank, mean, and standard deviation will let you know which is performing good, and which hyperparameter you know technique or method to use, either randomized or grid search. It will all depend on your data set, the size of your data, the time, the computational cost, the resources you have at hand, and much more. So that's it for this video, and in the next we will see the pipelines in machine learning. So till then, thank you, and thank you for watching.